China has just made a move few expected, a quiet decision with massive consequences that is already sending shockwaves through the global technology landscape. This is not a routine trade dispute or a fleeting headline. This is a turning point that could reshape microchip production, military technology, and the balance of power between the world's two largest economies. Every smartphone, electric vehicle, and fighter jet depends on rare earth minerals and advanced semiconductors. Invisible to most, these materials are the backbone of the modern world. China controls a significant portion of this supply, a fact long accepted as a reality. Today, that control is being used as a strategic lever, a tool of power. China has begun tightening its grip on critical rare earth materials essential for semiconductor manufacturing. These resources cannot be replaced easily, mined quickly, or processed just anywhere. When China acted, the impact was immediate. Factories paused, supply chains were stressed, prices fluctuated, and governments took notice. The first shock was only the beginning. A major U.S. chip company then openly criticized Washington's policies in public, accusing the government of harming its business, weakening its competitiveness, and handing advantage to China. This is not a minor disagreement. It is a fracture in the American tech front at a time when unity is crucial. Then came discussion of government intervention and potential price controls. Historically avoided in U.S. free markets, such measures now indicate urgency and concern. When a government considers controlling prices in a high-tech industry, the consequences are no longer theoretical, they are real and imminent. This story goes beyond headlines. There are hidden risks to smaller nations, pressures on supply chains, and questions of who will control future technologies, from AI to advanced weapons. Most people see only the surface, a political debate, a corporate dispute. Beneath lies a struggle over materials few can name, machines most will never see, and decisions that could shape the next decade of global dominance. Rare earth elements are central to this struggle. Despite the name, rare earths are not particularly rare in the Earth's crust. Their scarcity lies in extraction and processing, which is costly and complex. This group of 17 metallic elements, including neodymium, dysprosium, and terbium, has unique magnetic, electrical, and optical properties. These make them essential for modern technology. In semiconductors, they improve speed, efficiency, and heat resistance, are used in polishing silicon wafers, strengthening components, and stabilizing chips in smartphones and laptops. They appear in speakers, vibration motors, cameras, and touchscreens. Electric vehicles rely on rare earths for high-performance motors and batteries. Renewable energy technologies, like wind turbines, need rare earth magnets for efficient electricity generation. In defense, these elements are critical for radar systems, missile guidance, fighter jet engines, night vision equipment, and satellite communications. Control over these materials translates directly into strategic power, a fact China has long understood. As China exerts this control, global companies and governments face unprecedented challenges. Supply chains are stressed, production delayed, and economic forecasts disrupted. U.S. policymakers are realizing that traditional free market mechanisms may no longer be enough to secure competitiveness and national security. Every decision, from price regulation to trade strategy, carries global consequences. This is more than economics. It is a story about technology, influence, and power affecting devices we use daily, energy we depend on, and the systems that protect nations. The coming years will reveal how countries respond to China's moves, how corporations navigate supply chain vulnerabilities, and how governments secure access to these essential materials. Rare earth elements may be invisible to most, but they are now among the most powerful levers of influence in the modern world. Understanding their role is key to grasping the broader geopolitical and technological struggles shaping our future. Many advanced military and high-tech systems rely on rare earth elements because of their unique ability to function under extreme conditions, including high temperatures, intense magnetic fields, and rapid electrical switching. Without them, modern defense systems would become heavier, less efficient, and significantly less precise. While these elements exist in various parts of the world, China dominates a critical stage of the supply chain: processing and refining. Refining rare earth elements is a highly complex, toxic, and environmentally damaging process. Over several decades, China invested heavily in this industry, building large-scale, sophisticated processing capacity. While many other countries reduced or shut down their own facilities due to cost and environmental concerns. As a result, China now controls the bulk of global rare earth refining and separation capacity, even for ores mined in other countries. This creates a strategic dependency for nations like the United States, which still relies heavily on Chinese refined rare earths. Even when raw materials are mined elsewhere, they often must be shipped to China for processing before being usable in American industries. A disruption at this stage could slow production across defense, renewable energy, consumer electronics, and artificial intelligence hardware sectors, while also impacting global supply chains. Recently, China has tightened control over the export of several critical minerals, including gallium, germanium, and antimony. These are not household names, but they are central to modern technology. Instead of an outright ban, Beijing introduced a licensing system requiring government approval for each shipment. This allows China to decide who receives these materials, in what quantities, and when. Gallium is essential for producing high-performance semiconductors used in 5G networks, radar systems, and advanced computing. Germanium is used in fiber optic cables, infrared imaging systems, and satellite technology. Antimony plays a vital role in flame retardants, batteries, and military-grade alloys. These materials are deeply embedded in both civilian and defense industries. They are not optional components but structural elements of the modern digital and military world. Restricting them is therefore far more than an economic maneuver. It is a strategic act that directly affects national security. For years, global markets operated under the assumption that such raw inputs would remain relatively stable and accessible. Companies and governments built entire supply chains on this expectation. Now, a single policy shift has shaken that foundation. The reason this is so powerful is straightforward. These materials are not easily replaced. Alternative sources are extremely limited, and even if new reserves are discovered, it can take years to establish the infrastructure needed for extraction, refining, and processing. In the meantime, industries must work with what they have or face slowed production, creating bottlenecks that ripple across multiple sectors. These bottlenecks affect everything from smartphones and electric vehicles to defense electronics, renewable energy systems, and advanced computing centers. Controlling these materials gives China enormous leverage over global supply chains. A delay in one shipment can impact dozens of industries in multiple countries. Export licenses held back can disrupt factory schedules, delay product launches, and increase global production costs. Companies and governments are forced into difficult choices: seek limited alternative suppliers, reduce production, or redesign products to use fewer of these materials. Solutions that take time, money, and technological adaptation. This situation also translates into political power. When technology, defense, and infrastructure depend on your approvals, every restriction becomes a strategic signal. For major U.S. chip companies like NVIDIA, the situation is complicated. These businesses are global, with supply chains, customers, and revenue streams deeply tied to China. While Washington views export controls as a tool to slow China's access to advanced computing power, companies must navigate the practical reality of maintaining operations, fulfilling contracts, and protecting profitability. The combination of China's control over critical refining, new export licensing, and the global reliance on these materials creates a leverage point unlike any other. It affects not just economics, but the strategic balance of technology, defense, and industry worldwide. Every delay, restriction, or shift in policy has consequences that echo far beyond trade, touching the future of national security, technological leadership, and global supply chain stability. Inside the industry, many see a very different outcome unfolding. U.S. export restrictions have limited the kinds of advanced chips American companies can sell to Chinese firms. At first glance, the goal was simple: slow China's technological progress. But the reality for companies like NVIDIA was far more complicated. China was not just another market, it was a major engine of growth. Data centers, AI startups, cloud computing firms, and research institutions across the country were significant customers for high-end processors. When these sales were blocked, revenue dropped. Yet the bigger problem came next. Rather than halting China's technological development, the restrictions accelerated it. Chinese companies began building their own alternatives at an unprecedented pace. Former customers were rapidly becoming competitors. Industry leaders started describing the export controls as a strategic misstep rather than a victory, arguing that U.S. policies were hurting American firms more than they slowed China's progress. Financial realities compounded the frustration. As American chipmakers pulled back, other suppliers filled the void, some domestic to China, others from countries willing to work with Chinese partners. Over time, U.S. firms began losing market share not just temporarily, but structurally. Once customers switch entire system architectures, returning to previous suppliers becomes difficult. This shift impacts more than short-term profits. It affects long-term influence. Losing market share in China means losing access to one of the largest testing grounds for AI, gaming hardware, and cloud computing. It also erodes partnerships, data flows, and software ecosystems that shape global technological standards. From the industry perspective, the cost is measured not just in billions of dollars, but in lost leadership and reduced global leverage. Scott Bessent, now serving as U.S. Treasury Secretary, sits at the center of this struggle, bridging financial policy, trade strategy, and national security. His role extends beyond budgets or market stabilization. In situations like this, he is a key voice guiding how the U.S. responds to economic pressure, particularly when linked to strategic materials and advanced technology. Bessent has highlighted the unusual step of considering price controls, direct government intervention to limit or influence the cost of critical goods. This could apply to rare earths, essential technologies, or energy-related components tied to national security. The goal is to prevent supply manipulation, extreme price spikes, or shortages that could disrupt domestic industries and defense supply chains. Bessent has framed China's tightening grip on rare earths and critical minerals not merely as an economic concern, but as part of a broader geopolitical strategy, a way to exert influence without military force. His worry is that if unchecked, this control could allow China to indirectly shape the production and pricing of high-tech goods worldwide. He also pushed back against speculation about a chips for rare earth deal, emphasizing there would be no simple swap of advanced semiconductor access for mineral access, as that could weaken long-term U.S. strategic positioning. Instead, Bessent points to a broader trade framework between the two countries, a fragile attempt to maintain communication and basic rules, preventing a total breakdown. Both sides are under pressure, trying to protect core interests without triggering full-scale economic confrontation. Yet for the U.S., one of the biggest vulnerabilities lies deep within its own supply chains. For years, efficiency and cost savings led American companies to rely heavily on Chinese processing for rare earths and other critical materials. This dependency, once seen as a practical solution, has now become a strategic risk that could define global technological competition for years to come. This dependence created a system that works only when everything flows smoothly. Once China tightens controls, that system becomes fragile. Even minor disruptions can slow or halt entire production lines. Defense contractors, electric vehicle manufacturers, renewable energy firms, and semiconductor producers all rely on inputs that cannot be replaced quickly. Building alternative supply routes takes years, massive investment, and political coordination. During this transition, vulnerability remains. For China, wielding rare earth dominance as a strategic tool carries its own risks. Other nations may accelerate efforts to develop their own mines, processing plants, and recycling technologies. New alliances could emerge to reduce dependence on Chinese supply chains. In attempting to strengthen its position, China also risks isolation, trade retaliation, and long-term erosion of trust. If customers perceive China as unreliable, they will eventually move away. Even if alternatives are costlier or less efficient in the short term, the shift could weaken the very influence China aims to protect. The global tech industry already feels pressure. Costs are rising, not just from material shortages, but from uncertainty. Companies facing unpredictable approvals or delays build larger inventories, diversify suppliers, and redesign products. All of this adds expense. Production schedules become unstable, product launches are delayed, and smaller firms without deep financial reserves feel the impact first. Over time, these pressures ripple across the entire industry. Investors react, stock prices fluctuate, and research budgets are reprioritized. In the long term, this dynamic could reshape the semiconductor and rare earth market. New processing hubs may emerge in different regions. Governments could increase subsidies for local production. Recycling programs and alternative materials may receive heavy investment. Supply chains might shift from centralized, cost-focused models toward decentralized, security-focused networks. The world could move from a single dominant supplier system to a fragmented regional model where control is shared but efficiency is reduced. This change would not only alter where materials come from, it would reshape how global technology is built and who influences its future. One possible scenario is that China doubles down. Rather than easing restrictions, it could tighten export rules further. Licensing could become more selective, quotas reduced, and processing approvals delayed. This would signal that access to critical materials is no longer guaranteed by market demand, but by political alignment and strategic priorities. Such a move would extend delays, raise costs, and deepen uncertainty, forcing global companies to rethink factory locations and sourcing strategies. A tighter grip could turn China's supply control into a long-term pressure point rather than a short-term warning. Another scenario envisions a sharper U.S. response. Washington could impose more aggressive trade measures, not just on advanced chips, but across technologies and materials. Tariffs, additional export restrictions, and stricter limits on Chinese tech firms could follow. This would expand economic conflict beyond semiconductors into sectors such as AI, renewable energy, and industrial manufacturing. While designed to slow China's technological progress, these measures would also increase costs for American companies and consumers. Supply chains optimized for efficiency would be forced into resilience mode, more expensive and less flexible. A third scenario involves both sides stepping back and seeking a controlled compromise. China might maintain its licensing system for rare earth exports, but make it more predictable for selected partners and industries. Instead of blanket restrictions, it could implement targeted approvals that maintain leverage without collapsing global production. The U.S., in turn, might limit price controls to sectors where national security or industrial survival is at risk. Rather than full confrontation, this path would create a calculated balance. Tension remains, but total disruption is avoided. Meanwhile, other countries are not standing still. U.S. allies, and even neutral nations, are working to build independent supply chains. New mining projects are being planned across Asia, Africa, Australia, and the Americas. Processing plants outside China are under consideration, despite high costs and technical complexity. Governments are offering subsidies, tax incentives, and long-term contracts to reduce dependence on a single source. Over time, this slow but steady shift could weaken China's dominance, though it requires major global restructuring. As these initiatives progress, supply chains may become more regional. Instead of one country controlling the center, clusters of production could emerge around allied nations. This would alter cost structures, technology standards, and political alliances. Competition would no longer be just China versus the U.S. Entire regional systems would vie to secure their own technological future. The situation now sits at a tense crossroads. China has tightened control over materials that underpin modern technology. A leading U.S. chipmaker has pushed back, challenging not a foreign rival alone, but its own government strategy, arguing that certain policies are damaging American competitiveness. Meanwhile, Washington has signaled intervention, suggesting that market forces alone may no longer ensure national security or economic stability. Each of these moves feeds into the other. China's export restrictions create pressure on global supply chains. That pressure hits U.S. chipmakers, whose dependence on international sales and stable inputs creates internal friction. Their backlash amplifies political pressure inside the United States, pushing the government towards stronger measures, including tighter regulations, potential price controls, and broader trade actions. A single decision triggers another, creating a chain reaction that carries consequences far beyond national borders. This is no longer simply a trade dispute. It has evolved into a contest over who controls the backbone of the digital age. Semiconductors underpin artificial intelligence, military systems, communication networks, energy grids, and financial infrastructure. Rare earth materials quietly enable this entire system. Whoever controls their flow shapes markets, security planning, technological standards, and long-term global power structures. Other nations are watching closely. Asian manufacturing hubs, European tech firms, and developing economies tied into global supply chains all face ripple effects. Disruptions in semiconductor production affect everything from consumer electronics to hospital equipment, while delays in rare earth exports slow renewable energy projects and defense upgrades. The consequences extend far beyond two nations' capitals. Boardrooms and government offices around the world are responding. Investments are being redirected, supply routes reconsidered, and industrial policies rewritten. Efficiency is no longer the primary goal. Control, resilience, and survival are. Economic strategy now overlaps with national defense. Corporate decisions influence geopolitical outcomes. Even a single mineral shipment or chip design choice can affect the global balance of power. We are entering an era where the lines between trade, technology, and security are fading. China is tightening its grip. The US is pushing back. The rest of the world is preparing for multiple outcomes simultaneously. What we are witnessing could reshape global power for decades, not with missiles or tanks, but through silicon, software, and supply chains. The central question now: what happens next? Will China yield first, or will the US be forced to compromise? Share your thoughts in the comments. We read every single one. If this breakdown helped clarify what is really happening, hit the like button. For more no-fluff coverage on US-China tech wars, supply chain tensions, and shifts in global power, subscribe to our channel and turn on notifications. In this conflict, the next move could change everything.